I love you guys. You're all like, just tell us already, Jeff. But come on, you remember, it starts with a C. Okay, there it is. All right, so 12b. Yeah, rad 5 minus rad 2. I want to do the denominator. So I want to multiply by rad 5 minus rad 2. Yeah, and then just FOIL. Don't forget, then the bottom doesn't just go away somehow magically. In this case, the bottom does become 5 minus 2. So it becomes 3. It doesn't just become 1. It doesn't go away. So pretty cool with that. I've built it to make the middle term rad 10 minus rad 10. I built it so the middle term goes away. And I think maybe some people feel like this is cheating. I can multiply top and bottom of this by anything that's not 0. Anything you want to. You can multiply top and bottom by the natural log of the square root of e to the 14.7 minus 1. All day long you can do that shit because it's not 0. But would that help you do anything? No, it wouldn't help you. So why would I do that? So I'm going to multiply by the thing that will help me. And this gets rid of all the radicals on the bottom. All the radicals are gone. And on the top, you just get a bunch of shit. I mean, you just multiply it out. 2 rad 5 minus 2 rad 2 minus rad 15 plus rad 6. All right, so it makes the top look a little worse, but the bottom looks so great now. 3, yes. Oh, bunch of people that worship 3. I don't know. That's right. Is that cool? And then 12c is the same thing. It's just remembering that I. What is I? What do I be? Yeah, square root of -1. It's a root. So what are you going to multiply by? 5 minus I. Same exact idea as this because it is a root. I know it's a freaky root, but math doesn't give a shit. It's a root. So times 5 minus I, blah, blah, blah. Become a 5 again. There you are. FOIL. And of course, the big thing about this, some people are still replacing I with -1. But what's I is in -1? I is the square root of -1. What's -1? I squared is -1. So once you FOIL any I squares, it becomes -1. Cool.
Can you go over 1F?
So what's the deal with 1F? That's the problem where it takes way too long for some people, because what do you think some people might do to that problem? FOIL. Oh my God. FOILing is only if you're multiplying expressions. This one I'm subtracting expressions. So what's the only thing I got to be careful about? Because it is subtraction of expressions. Distribute the negative through that second dude. Right? And what's in front of the 6w cubed plus 3, all that? What's in front of that expression? 1. So they don't change. But what's in front of the other expression? -1. So everything's got to change. And then you just put your like terms together. Right? So if on 1F, somebody told me that they found 3 W6s, I always say the same thing. I'm like, I don't see any W6s. How'd you get 3 of them? Holy shit. Right? Do you guys see? But the reason they do that is because they added the powers. Well, what's the only time you add powers? When you are multiplying. There's no multiplication. Exponents are based on multiplication, so they will not change unless you multiply. That's it. Like it. Is that cool for 1F? It's really just a like terms problem. You just got to be careful about that negative changing the signs in the second dude. I like it.
So for 1C, you would just distribute the 2x minus 3.
Totally. I love it. So that is multiplication, so you would just distribute each of the 2x and the -3. And some of you guys might realize ahead of time that, is that right? Did I make this special? It looks like it did. Yeah, what is that? 2x minus 3 times 4x squared plus 6x plus 9. Do you guys see what pattern it's in? It's a cubes. Yeah, so a lot of stuff's going to, do you have to see that ahead of time? No, but you're going to see a lot of stuff cancel. So little dude, big dude, that's coming together to create a little two-term cubes. Yes?
If we can see that on the final, do we still have to show all of our work?
Oh, you can say real quick, oh, it's cubes, and then the little tears would come out, because that's the whole point of math, is to find patterns and then use the patterns you found to make things quicker. That's not the whole point of math. That's a huge part of it. Right? So, I mean, as long as you tell me what's going on, if you just put the answer down, I'm like, I'm not exactly sure where that came from. You know? But if you say, oh, yeah, this is just the cubes, bam. Sweet. You saved yourself some time using good math techniques that kicks ass. That's awesome.
For 1j with negative 27 raised to the 4/3, you make that a root, right? A cube root.
Yeah, I would.
And then raise the answer of the cube root to the 4th power.
Exactly.
You have to do that before.
Yeah, so the very first thing I would do, actually, to be honest, what's the very first thing I would do?
It's negative
'Cause I'm weird.
27 raised to the 4/3.
Oh, okay. Sorry. Thank you. So if it was that, I would have flipped it.
Flipped it, yeah.
But here I don't have to flip it. Cool. So now you can rewrite it as cube root.
And then you just raise that answer to the
And some people still freak themselves out by putting the 4 in the inside.
Yeah, that's what I was
Whew. You can. It's an option. But shit, no. I know what the cube root of negative 27 is, and then I can just raise that to the 4th power. It's much better. And I don't know. Are you guys, is anybody still like, why the shit can I do it either way? What's up with that? Why? And I tried to do something else 2 different ways, and you're like, oh, no. And then here you're like, oh, yeah. Well, it's got to be backed up by logic. It's got to actually flesh. So really, negative 27 to the 4/3 is the same thing as this, right? Because what would you do with the powers here? Multiply. So these are the same things. This and this are the same. And this would be the cube root with negative 27 to the 4th power on the inside. But do these have to be 4 and 1/3 to be multiplied to be 4/3? No, it could be the other way around. So it could be negative 27 to the 1/3. And that's what I put here. Cube root of negative 27 inside of a 4th power. That's the way I used it. Why did I do that? Because it's so much easier that way. And it's based on something that is true. The product doesn't matter what order the things are in. Okay, maybe.
So the product of that isn't imaginary because it's
It's not imaginary because it's an odd root. Odd roots, totally lay back. Imaginary numbers had to be invented just because even roots are so picky. So we're like, all right, we got to make a special little thing for just for you, and then, but even odd roots are like, whatever, man. You're negative? The answer's negative.
Can you do anything for 1n?
Yes. Yeah, well, why I like that you think you can't, to be honest, even though that's wrong. I still like that because on the surface of it, you can't do shit for this dude. Why not?
Well, you can't pull the x in the second out because it's not high enough to be pulled out.
Yeah, but more fundamentally, the roots
Aren't the same.
aren't the same. But the bases are the same. So multiplication doesn't need completely like terms. Very often what multiplication needs is somewhat like in some way. I don't know if you guys see it. So addition, subtraction, it's got to be exactly like terms. You can't do shit. Multiplication, division, always more lenient. How much more lenient? Well, it depends on what you're doing. So here it's not the same root, but it is the same base. And the word I just used, the base, is a clue as to what to do here. I write this as x to the 1/3, x to the, careful, 3/4. Remember, roots, like on plants, are on the bottom. Most plants. In case there's any botany people in here. I had that happen one semester. That's why I always say that now. Like 6 years ago or something. I'm like, roots on the bottom plants. No, they're not all of them. Oh my God. Most plants, all right? And so now I'm careful. And now what do? Of course,
And
add them. And remember, I love that you thought you couldn't do anything. That's sort of okay, except you lose a lot of points if you didn't do anything. But I understand why you think you couldn't. But now, in the process of adding these, what do you have to do? Get a common denominator. And what's the denominator? The root. So if you get a common denominator, you are getting a common root. Let me see if you guys see this. So that one, you just add the powers, blah, blah, blah. Watch this. This is interesting. The fourth root of x squared is the same thing as the square root of x. Because 2/4 is 1/2, right? I mean, that's... So, you remember how I said I wish we didn't have radical notation, but we use it so much, and then we teach you this later? If we would just use this always, you would know 8 to the 1/3 is 2. You wouldn't have to write it in cube root form or something. I don't know if you see what I'm saying. You would know how to do this without having to write it. If you used nothing but radical notation, we never made this come about. We would just teach you this directly. But it's so much easier as fractions because you already know how fractions work. That's why that method, writing it as fractional powers, makes more sense. Okay. So what could you do with this then?
y squared to be 1/5. Is it not the same base?
Yeah, they don't have the same base, but they do have the same root. So what do you do when they have the same root? You just... Yeah, so this is not really a trick question, but the only reason you had to do fractional powers is because the roots weren't the same. So you had to make it more focused on the base. Yeah, the roots are the same. You ain't got to do shit. Just put them all under the same root. If the roots are the same, it's awesome. Just put them together. Oh, okay. I like that most of you guys completely get the radical thing. Is that the one you want to do?
It's just do I multiply when I break down the 50?
Yeah, so for this part of it, 2 square root of 50, what's the operation between the 2 and the square root of 50? What's the operation? Multiplication, there you go. Right? So it'd be 2 times the square root of 25 times the square root of 2. 2 times 5, 10. So really the short answer to your question is any numbers that come out, that you do the radical of, multiplies by whatever's there already. Why? Because it is multiplication. That's why. Yeah. Yeah. So 1E, what kind of problem is that? I mean, what do you basically have to do for 1E? So I was like, I don't know, man. That's why I asked. Factor. Cross divide, yeah. I like it. So it's just a way for me to put 4 factoring problems possibly in one, right? In this case, it's only 3 factoring problems, so I didn't fully utilize what I could have done. Remember also, do you guys see the cube in this dude, right? X cubed minus 27? And up here, you're going to get some GCF times something. Remember, if you have a cube in the problem, one of the trinomials might be the big dude. So don't kill yourself if you can't see how to factor a trinomial. Maybe it's going to cancel, and maybe it's the big dude of a cube in the problem. So if I were you, I would factor the cube first. So then I can quickly see that and not waste time trying to factor x squared plus 3x plus 9. It's not going to factor. Is that cool, Saba? Yeah.
Can you do number 2? The word problem.
Which one?
2A.
So, for word problems, the main thing to realize is, I don't care how good at math you are, there are very few people who are able to just jump straight to the equation. So the very first step in a word problem is not mathematical at all. There's no math involved in the very first step. And this is the step that people always skip. I'm like, wait a minute, don't you not like math? So maybe we should do this step that has no math in it. What are the players in this problem? How many players are there?
3.
Yeah, and who are they? Frank, who are the players in number 2A?
A, B, and C. A, B, C.
No, don't say that. Don't say what he said just because he said it. It's not quite right. I want you to use the same language that they do in the problem. So what are the players in that problem? What are they physically? What's involved here? We're looking at the what of a what?
I don't know.
A,
So what are we looking at? We're looking at a triangle, right?
Yeah.
What about the triangle? The what's of the triangle? The sides of the triangle, right? And what does this problem call those sides? One of them it calls it the one side, right?
The name is Neo.
So we got the one side, right? That the agents are trying to stop. And what's the next side we see mentioned?
The largest side.
Sure, you skipped one. That's all right. So I see a largest side. And what's the other one?
3 less than twice the smallest.
Smallest. See, and right now on this step of the problem, I don't give a shit about 3 less than, 72, any numbers, any operations. Completely not mathematical. Just write the names. Could be people, could be sides. Use the same words the problem does, because then you can always relate them. So who's going to be just x? That's the next step. Yeah, why is the smallest going to be just x?
The other sides are modified.
Yeah, both of the other sides modify the smallest. I got to know the smallest one first. So if I call the smallest one anything you want to. Okay. The one side would be 3 less than twice, and the biggest mistake there is people just write that, which doesn't make any sense. Doesn't make any sense. If I had $10 and you have 3 less than me, how much money you got? 7, not -7. 3 less than 10 is 10 minus 3. That's an English grammar problem. It's not a math problem. English grammar is freaky. If you learned English second, you know what I mean. All too well. 3 less than twice. So 3 less than twice the smallest. And the largest is 5 more than 3 times. You can't go wrong with more than, because it's addition. Who cares? 5 more than 3 times. How do you write that? 3x plus 5, or 5 plus 3x, or something. Okay. So now so English names of everything involved, math names of everything involved. Why do I have to give the math names? Because math names are the only things that work in equations. I can't combine like terms between the words. Doesn't make any sense. So what's the equation going to be now? What's the overall relationship? What do they all have to do? Does one side equal the largest side? What's the relationship?
We add
Add them to become 62. So this side plus that side plus that side, 62. The biggest mistake is either the one thing I told you about turning this around, or forgetting this poor side because you skipped this step and you saw 3 less than 2x and you saw 5 more than 3x and you're like, I got this. And you forgot this dude. Poor little x dude. So you get answers like 11.785, and which is possible, but normally I try to make the numbers come out whole numbers so it's quick to check.
How'd you find the largest side? I don't know how'd you get the 3x plus 5.
What's it say about the largest side?
5 more than 3 times the smallest.
What's 3 times the smallest?
Okay.
Yeah, so the smallest is x. So 3 times the smallest is 3x, and then 5 more, add 5 on top. I like it. So that's the whole idea. That's why finding who is just x is actually almost the most important step of a problem, because you can't build the other things until you've done that. So this is sometimes called math modeling. Right? Does this number have to be 62 for this problem to work? No. But in order to make it 62, there's only one value of x that makes all these the right numbers to make it 62. If I didn't want those, I could make this different and get a bigger triangle or a smaller triangle. So I'm modeling a triangle that has these relationships between the sides, and then I want the triangle that has this perimeter. So there's an infinite number of triangles that match this. Because for every value of x you can imagine, these work. Of course, it's got to be greater than 0 to make sense physically. But I want the one that has a perimeter of 62. There's only one triangle that does that. Let me see if this will work. You guys go with me for a second. Just go with me. Let me see if this does anything for anybody. Help me make a triangle. Just somebody give me a side of a triangle. Tell me how long is this side of the triangle? Just give me something. 5. Who said 3 over there? All right, now you tell me this side. 10. 11. And what's this last side? Somebody else? I don't want to play. Anybody? Give me a number that's maybe bigger than 10. And listen a little bit.
12.
12 is crazy. Oh my God, holy shit. Okay. Now, what kind of a math problem could I make from this? Now, this is not real life math. I know that, and I don't give a shit. I want to show you one way to kind of create a problem. What relationships can you see? Well, obviously, that's the smallest one. And that's the middle one. And that's the largest one. So you can use those words if you want to. Right? So what if we say, now how's the largest related to the middle? 2 more. Okay, so I can say the largest side is 2 more than the middle. So I sort of set up the middle to be what everybody depends on. How does the smallest side relate to the middle? Half of it. Oh, I like the way you said it. That's beautiful. Not 5 less, but half. Kick ass. The smallest, Jeff, why do you keep leaving the last letter? Is half the middle. The perimeter is what? 27. So what would the equations, we know the answer already because that's where we started. But what would the equations be? Who would be just x? The middle. So what would the largest side be in terms of that? X plus 2. And what would the smallest side be? 1/2 x. Cool, I love it. And then what would these all have to be doing together? I love it. I love the way you guys set this problem up with the fraction inside of it. But you could immediately, right now, kill it if you want to, if you remember how. How would you kill that fraction? Double everything. Right. So 2x plus 2x plus 4 plus x equals 54. Do you guys see that? Is that cool? Anytime you have a fraction in an equation, there are 2 sides. I'm allowed to multiply by whatever I want to. I'm going to multiply by 2 both sides because that's going to kill that fraction, right? Twice, 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 twice. Same equations. Believe it or not. And now let's solve it real quick. For 5x, subtract 4, I get 5x is 50, so I get x is 10. Holy shit. Of course I get x is 10. I mean, we made the damn thing, didn't we? X is 10, largest is 12, half x is 5. We get that. Yeah, there you go. So it's describing relationships between things. And in real life, it very often happens that we come in after something's happened and we can see how things are related, but we don't know what it was to begin with. I mean, and that's what algebra does. It works backwards. So believe it or not, algebra has a big role in forensics, criminal investigations. Good Lord, man. Because you got to work backwards. That's what algebra does. Okay. Sorry, I cut somebody off earlier, and you need your stuff back. So was somebody asking a question earlier, and I just like, shut up. Who was that? Somebody was asking a question, and now I've scared them.
2b, are we just gonna write 3x plus 2 equal to 261?
Yeah, I think 2b, did I have that on an earlier practice test? No. Oh. So on 2b, I would highly recommend you draw a picture, but that isn't necessary. What are the players in 2b?
The length.
Length and width. So in English, what are the players? Now you're going to start translating into Mathish, and normally the first step for that is who's going to be just X. So who does the other thing depend on? The width. I got to know the width first, and then I can do shit to it to figure out what the length is. So I got it to call the width X or W, whatever. And then what's the length going to be?
3x plus 2.
3x plus 2. And this problem is all about the what geometrically, the what of the rectangle. Area.
Here, so we multiply that.
Good. So x times 3x plus 2. That's the area of that rectangle. And we know the area of the rectangle has to be
261.
261. I know, but that's meters squared. It's just units. When you're working out an equation, you have to put units in. They just get in the way. And now, what do?
FOIL.
Yeah, you distribute, you suck that over, you make it equal to 0, right? And you try to refactor it. I think for sure I put this on an earlier something or other. I probably just stole it from this. This seems very familiar because it was a really, really gross number to work with. Somebody's like, I agree with that statement. But remember, I wish more people would show you. What do you get there? My brain doesn't want to work. 781? Is that what you get? 781? Is that right? 783. All right. And then I want to find factors of 783 that add to be 2. Well, that seems difficult.
All those numbers add up.
Say again?
Those numbers add up to be by 3.
Oh yeah, so 15, 18, sure. It's divisible by 3, sure. So yeah, you could take 3 times what?
260.
Yeah, 3 times 261. That's why they're divisible by 3, because 3 went into their product. But that doesn't make 2. So I hate when teachers teach factoring and they just stick with finding a list of factors. I love the reaction I got from my colleagues when I said, why don't you just find numbers that add to be 2? And like, because that list would be infinitely long. No, you don't make the whole damn list, you silly people. You find one, you see how far off you are, and then you try to adjust it a little bit. You don't make the whole list. For these, you make the whole list of factors, and then you step back and see who adds to be 2. All right, that's fine. It's a nice closed list, Jeff. It's not infinite. No, screw you. Just what adds to be 2, right? They have to be different signs, right? So they have to subtract to be 2. So let me start. It's not going to be like 10 and 8. It's not going to be anywhere near enough. It's got to be 783 when you multiply. So maybe 20 and 18 to start off with, just to get something down here. 20 and 18 would add to be 2 if the 18 was negative. But what do they multiply to be? 360. Nowhere near enough. Right? So then, okay. Guess what you're going to do? It's not big enough, so I'm going to make the numbers bigger, but they still have to be 2 apart. So maybe 25 and 23. If the 23 is negative, it makes 2. But what do those multiply to be?
575.
All right, I'm getting closer. I'm getting closer. Do you guys, this is more of a Price is Right game. I know. I think hopefully I said that before. Higher, lower, right? So if I do 30 and 28, just to purposefully get the wrong thing, I get something. 840? No, too big. So now just step it back. Maybe 29 and 27. 783. There you go. I just need 2 numbers that multiply to be this and add to be this, they don't have to do either one of those first. They just have to do both. So you make several that do one of them, and then check to see if it do the other one. If it doesn't, screw it, screw it, screw it. Yay! Right? The factoring thing will drive you insane. This will actually hone in on the answer. Someday I'll convince my colleagues that that makes some sense to teach it that way. It's crazy. Yeah. All right. Is that decent? Now, what do I do with this, of course? What do I do with these numbers? Holy shit. Remember what we were doing? Factoring this? What do I do with the numbers I just found?
Plug them back in.
Yeah, put them in here. Replace the 2x with, I'll put the negative 27x first, plus 29x, and then you group, factor, blah, blah, blah. One answer will be negative. Hopefully you throw that out pretty quickly. X can't be negative. If you do build something that has a negative side length, please call me and have it come over. No matter what's happening. Yes?
Oh, negative 3. Third.
It's not a third because you don't want to cube root the 2. You got to raise 2 to the third power and make it 8, but then, like you just said, you also have to negative power. So negative 3 is exactly right. You have to flip it and cube it. Yeah.
While you're doing the word problems, did you do invariant?
Oh, yeah, cool. I like it. Two numbers add to 14.
So x plus 1 equals 14.
Beautiful. X plus y equals 14. What is the largest product of one of the numbers and twice the other? So take one of the numbers
X,
times twice the other one.
2y.
And I'm going to call it, just for the sake of giving this a name, I'm going to call this the product function. Because that's what it really is. It's the product of the two. So I get product equals 2xy. Now what is wrong with this expression in terms of what we're used to doing? We're used to dealing with formulas that only have one variable. That's when we're able to, in fact, we had the whole system of equations. We're like, kill the variables. There's too many of them. Well, here I'm not going to kill a variable.
You just set it equal to a variable.
I know this is true, right? So here's, normally, this is called an optimization problem. You see why we would call it that? If I want to optimize the size of my number, the product, make it the biggest it could be, or I want to optimize profit, or I want to minimize cost, it's called an optimization problem. I will tell you something, and I will ask you something. Use what I tell you in what I ask you. How do I do that shit? Well, if only I knew what y was in terms of x. Well, how do I do that?
Subtract x.
Subtract x. So I know that. I know for a fact that y has to be 14 minus x. So wherever I see y, I can replace it with 14 minus x. Now what happens to this when I do that?
X minus 2x squared.
Cool. And what is this? Why is it now easy to find the largest product? Because what kind of thing is this if I were to graph it? If I graph this, what would it look like? You guys can do it. Parabola, but be careful, opening, because the x squared piece is minus. So why does it make sense then I'm looking for the largest? Because there is one, right? If it opens down, there is a largest. So, and that is going to occur at the what? And how do I find a vertex quickly? Negative b over 2a. Yeah. So optimization problems for this class and for 176. Oh shit, yeah, you're going to be doing a lot of these in pre-calculus. Why? Because it's something that happens in real life all the time. You have a restriction and then you have a requirement in real life. Well, we can't afford this much, but we need this, all right? Well, you take the restriction and you put it in the requirement and then you try to optimize it. This is kind of like what happens a lot in real life. This is what the algebra take on that looks like. So x equals negative b over 2a. Now be careful. What's b? Good. Not just this because it's second. This because it's in front of the x. ax squared plus bx. Negative 28 over twice. Negative 2. Seven. If x is 7, what's y? 7. And then what's the biggest product going to be then? Yeah, it'll be 2 times x times y. So it'll be 98. That's the biggest product. I think on the answer key I forgot to double it, but oh well. I made up for it just now. So, I mean, I'm asking you, if I just said, what's the largest product of two numbers? You'd be like, there is no, what the hell are you talking about? If they have to add to 14, okay, now that I can find an answer to that. If they have to add to 14, they can't just be as big as they want to be. They have to add to 14, now there is an answer to that. So I use this extra information in the question I was asked, and that makes it possible to answer. It's impossible to answer this question. Because here, x and y can be whatever the freak they want to be. How big can you make that? As big as you want. But if they have to do this, no, there's a limit. They can only get up to 98 then. And what shape would this take? If this was the area of a shape, of a rectangle, this would take the shape of a square. A square is almost always the answer to an optimization problem in some way. Some quadrilateral shape, and it's going to be a square almost always in some way. Okay.
Can you do 5/8?
So Frank, what's the equation of a line? There's two of them. Tell me one of them. Equation of a line. General equation of a line. I'll get you started. Y equals for a line. Frank's like, why'd you put me on the spot, man? You suck, Jeff. M.
Starts with the M, right?
Yes. M.
MX
X.
plus B.
You got it. Cool. And what's the other one? Y minus
Y1.
Y1 equals.
Then X minus X1.
If I put this down here, then it's just the slope equation, right? Of course there's an M there. Okay. All right. So what's the best situation? If I wanted to find the equation of a line, wouldn't it be just fantastic if I told you the slope and I told you the y piece of the y-intercept? I just have to plug this in, I'm done. Because that's what M is the slope, and B is the y-intercept, the y piece. What do I tell you in part A? I tell you the slope, and I tell you the y-intercept. How do I know this is a y-intercept? Because it starts with a 0. I love it. So there's no work to be done. You just have to put those in the right place. So y equals negative 1/3 x minus 5. Put the m in, put the b in. You're done. I like it. And sometimes that's a hard problem because you're expected to take more work.
That's it.
That's it. So it's really just testing to make sure. Do you know what M and B mean? Right? Good Lord. Now, if you use this, will it work? Yes, but you're just doing more work. Of course this will work. That's a general equation of a line. Yeah.
You have to do that second equation for like part B where it's asking to find the line parallel to it.
Yeah, you can. To be honest, you could use this one too. But the way I showed is I use this one. So for part B, it's going to be parallel to y equals 5x minus 5. What's the slope going to be for mine? 5, because the slope of that one is 5. If I would have said perpendicular, what would my slope have been? Negative. So perpendicular is all the opposites, right? Change the sign and flip it. Parallel is exactly the same. And I know the point, -4, 2, so I know x1, y1. And now you just got to plug and chug in there. Right, so it'll be y minus 2 equals m times x minus -4, so plus 4. And now just solve for y normally is what I want you to do. Put it in the most compact form. Now real quick, just to show you. Some of you guys know how to do this, but to be honest, so here I get 5x plus 20, add 2, I get 5x plus 22, right? Okay, now watch. I could use this formula, to be honest. Y equals mx plus b. Because as I move along a line, if I look at one point and then I look at another point, will the lines intercept or slope change just because I'm looking at a different point? If I have a line that exists and I go, let me look here, will the y-intercept go, oh shit, let me move around? No, it's a freaking line. It's not going to go anywhere. So watch. I know that when y is 2, and I know the m is 5, then x is -4. I don't know what b is, so I can solve for b. I get 2 equals -20 plus b. I get b is, at 20 freaking 2, right? So that's just, the thing that people forget when they do this is they stop here. And I ask for the equation of a line, you better put it into mx plus b form. But it's just directly finding what b is. I like it. Some of you guys might realize, if I know the slope at a point, I should be able to work backwards and figure out what the y-intercept would be. I should be able to move over to the y-intercept, and that's what this does algebraically. It just tells me where the y-intercept would have to be. If you don't like any of this, then just do this. If you don't like this either, then you're screwed. Sorry. You gotta be able to do one way or the other. You don't have to like it, but you just have to be able to do it. No, that's the one I can't do, Rose. No, I'm sorry. Yeah, I love this. I'm sorry, man. No, I can't. The thing that freaks people out on this one is the extra letters. But if you just do the steps for the surefire method, it just puts everything in the right place for you. You just have to worry about the coefficients. What do I mean by that? Well, what's the first step there because of that 5? Right, well, is there a GCF there? You're talking about this one here, right?
Yeah.
5x squared minus 7xc minus 6c squared. So what's the first step? Yeah, got to take that 5 into account. So now I need factors of -30 that add to be -7. That's pretty straightforward. Yeah, -10 and 3. Is that cool so far? So if there's a 1 there, 1 times this stays this. That's why I could just focus on this number. But that's the 5 there. 5 times this is something else. But I still do the same thing. Find 2 numbers that multiply with this, add to be this. And now what do I do with those 2 things? Yeah, put them in here, right? So it'll be 5x squared minus 10 xz plus 3xz. You are rewriting this. So whatever you put here, this better still become this. Does that make sense? So whatever letters are here, they better be here and here so that they're like terms and they become that. And now what can I do?
We're just breaking these out into parts.
Yeah, break them down into 2 parts. Group. Yeah. So then you group. Blah, blah, blah. Now let me ask you this. If I gave you this problem, this should be easy. What you got, Jeff? Sure. How would you factor that?
X plus 4, X plus 1.
Beautiful. Now, Don was thinking to himself, that was no big deal. What the shit was that? Well, how would you factor this now? Well, what do you put first?
X.
X and x, right? Why? Because x times x is x squared. So what are you going to put last? B and b. Why? Because b times b is b squared. And now you just put the same damn numbers now, because now you're just worried about the coefficients. So it'll still be plus 4 plus 1, right? And you'll notice now I get 4bx plus 1bx is 5bx, or xb. So, you know, if you don't, grouping is nice because it does that for you. If there's more letters in there, you just put the letters in there so that they show up.
Does that will work for A2?
Well, I mean, the reason that's a little different is here I got a number out front that's not 1.
Yeah.
So I have a different method. And to be honest, the method makes extra letter stuff easy. I mean, if you've done this now, you take a 5x out, right? Get x minus 2z. See how it takes care of the letters for you? The process does, right? You didn't have to know to put a z at the end. There just is a freaking z at the end as you do this. Over there, you're the one that has to put the b's in. Because you see there are b's at the end, you better put b's at the end. Maybe. Plus 3z, x minus 2z, blah, 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 right? You see that? So here you have z's at the end, right?
Yeah.
Which makes sense because I have z's at the end. 3 times negative 2z is negative 6z squared. Bam! But did I have to worry about that directly? No. Over there? Yeah. I got to make it show up. How do I do it? The same way I make x squared show up. X squared, xx, b squared, bb. Not a big deal. Put them at the end because they're at the end. Yes?
Do you have an extra copy of the practice?
Yes, I do. I like that. That's the easy question. You're all asking yourself, why did I take this over this summer? Yes?
With a 40, when you factor, would you use imaginary numbers to finish factoring, or would you just use it as a point?
Oh, I mean, you could, but normally when I say factor,
With all real
I would have to say factor completely using complex numbers. Because if I just say, like domain, if I just say find the domain, you wouldn't give me any complex answers. I'd have to say find the domain over the complex numbers. If I say factor, you don't have to break down the complex. If I say factor using complex numbers, which I've been known to do.
Yeah.
So if I said factor this using complex numbers, how would you do that?
X plus 3i, x minus 3.
Yeah, x plus 3i, x minus 3i. The problem with factoring this before was there's no real number that when you multiply it by its additive inverse, by the negative of it, it comes out to be positive. There's none. But there are imaginary numbers that do this all day long. Freaky shit.
So the answer for that one will be 10y minus
Where are we at? Sorry?
for the same question? I said 4d.
4D, sorry. But 4B, yeah, 10y. And what's left inside then?
Y squared minus 3y minus
Y squared minus
9.
9. And then that factor is like nice, because it says difference of squares. I can use real numbers. Sum of squares, I have to use imaginary numbers. How would you factor this using real numbers? Factor that using real numbers. I don't need the complex numbers because there's not a plus there, but... Well, how do you do this? Yeah, x minus the square root of 4, x plus the square root of 4. Of course, because square root of x squared x, square root of 4 is 2. So how do you factor x squared minus 2? X minus square root of 2, x plus the square root of 2. It's just We normally don't go do numbers that would show up as explicit radicals. We do numbers that would show up as rational numbers. But do we have to stop at No, we could take that next step and go here. So if this equals 0, then what the answer is going to be? Plus and minus rad 2. Yeah. So you see now, the way you hopefully would solve this, to be honest, would be to move the 2 over and then take a square root. But what you better put... Why? Because that's a shortcut. You got to remember what's actually happening when you want to do a shortcut. That's why plus or minus should be just a second nature when you take a square root. Because you're really doing a shortcut. Shortcuts normally involve remembering something. Do you guys remember when I asked you to solve this? This is kind of related to this question that just happened. Solve this. If you get y equals 5 and that's it, you're going to lose a lot of points. Yeah, subtract 125. And then the big dude. The little dude will be easy. The big dude, you'll have to do quadratic formula more than likely. Or well, definitely, because it won't factor. And then you'll get complex answers. I like it. Did I show you? I mean, the one answer you get is 5. And the other two answers you get are the same angle away. So they're going to be complex numbers, but it's actually based on angles. I don't know if I told you that or not, but that's more than you have to know. I'm sorry. It deals with like partial turns to get all the way around. Go away. You're scared. Stop. Yes.
Can I just explain a little bit about the big dude thing?
All right.
I don't know, this is whenever
So,
I'm trying to solve.
all right. So this one,
Yeah.
that's y. This is 5. So what goes in the little dude? Yeah, 1y minus 1, 5. So those other two y's have to go here, so I do get y cubed.
Okay.
Those other two 5's have to go here, so I do get negative 125.
Then you get 5y.
And in the middle, yeah, exactly, positive 5y. There you go. What's that? 1 of each, 2 of each, product in the middle. Closest to a song I'll ever get.
Not the answer.
Huh?
That's not the answer.
It's not the answer, but that's how you factor that, sure. And then you get y equals 5, or y equals negative b plus or minus blah, 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 right? You can't factor this, so you have to use quadratic formula. Yeah. Oh, yeah, let's do 14. And I think I'll give you the answer key. I got tired at the end, so there's several I want to do on the board up here. 14. All right, so what is the